In the earlier question, we saw two important terms, namely stereospecificity and stereoselectivity. That relates to how the products and the starting materials are stereochemically oriented to give different or various types of products. In this case, in this particular question, explain what is meant by regioselectivity. Regioselective, for example, Markovnikov addition is actually a regioselective reaction. And explain what is meant by regioselectivity. Regioselectivity means the particular groups attached to a particular position, a particular carbon atom in the reaction. As for example, when you take the hydration of acetylene, is a regioselective reaction. When you take acetylene, it gives rise to acetaldehyde. That is, when it is treated with mercuric sulfate in the presence of sulfuric acid, this will give rise to an enol, which will further tautomerize to give rise to acetaldehyde. So this is simply Markovnikov type of addition. One hydrogen and gets attached here, the other OH gets attached here. As far as acetylene is concerned, there is nothing much as stereoselectivity because two carbon atoms are identical. Now let us take another example in which C6H5, C triple bond C, CH3. In this particular compound, this is also an acetylenic compound. On one side of the acetylenic bond, we have a phenyl group. On the other side, we have a methyl group. When this is subjected to, this is just nothing but hydration. The hydration, direct addition of water is not there, but the addition of water is affected through mercuric sulfate and sulfuric acid. Mercuric sulfate, that is mercury in the higher oxidation state, and then sulfuric acid. What will be the product that is obtained? Effectively, this is also addition of water, that is hydration reaction. That means H and OH are being added. The question is whether H is added to this or H is added to this. When H is added to this, OH will be added to this, or when H is added to this, OH will be added to this, and which will be the preferred one. Now, in this particular reaction, you will find a carbocation will be produced on this particular one. Therefore, OH will be added to this and H will be added to this to give rise to this intermediate, which is an enol. This enol is now will tautomerize to give rise to, will undergo tautomerization. Tautomerism is a process by means of which a proton shifts over from one position to 1,3 prototropic shift is known as tautomerism. Therefore, this will rearrange to a ketone to give, which will be this product. So, we will always get a product which is when this compound C6H5 C triple bond C CH3 is treated with mercuric sulfate in the presence of sulfuric acid, or in other words, when it is hydrated, when this acetylenic bond is hydrated, the ketone that is obtained is always C6H5 CO CH2 CH3 and not C6H5 CH2 CO CH3. This is a regioselective or regiospecific type of reaction. That is why it is given a particular way of attachment to this particular group. The elements of water H and OH, they get attached to two different carbon atoms which are different. Supposing it is a symmetrical olefin, symmetrical alkyne like CH3 C triple bond C CH3, then there will not be any difference. But this is a sort of an unsymmetrical alkyne. They have a phenyl group here and a methyl group on the other side. We get two different types of products are likely to be obtained, but this is the preferred product that is obtained. The other product is not obtained because of the stability of the benzylic carbocation is likely to be developed during the process.